The parabola is defined as the set of all points such that the distance from a point to the directrix equals the distance from the point to the focus. Here's our parabola. There is a point inside the parabola called the focus, and a line on the opposite side of the vertex called the directrix. And what the definition is telling us is that this parabola is made up of all the different points, so that if we looked at the distance from a point to the focus, it would be the same distance from that point straight down, perpendicular to the directrix. So if we take this point right here, let's pick a line from this point to the focus, and that will make a line from this point down to the directrix. And the lengths of these two lines equal. And this applies to any point that we pick. Let's pick another point and show, and if you have a ruler handy, you could actually put it up to the screen and measure and see that these two lines have the exact same length. But let's pick a different point and check that out too. Let's choose a point close to the vertex right here. The distance from this point to the focus, and then the distance from this point to the directrix. This distance is always measured as the shortest, so the line is perpendicular to the directrix. And these two lines have the same length also. So each of these points is placed so that the line from it to the directrix has the same length as the line from it to the focus. A result of this shape is something that we see in satellite dishes or in flashlights. With a flashlight, the focus would be where the light bulb is placed, and the parabola is the mirrored disc surrounding the flashlight. Points coming from the focus or the light bulb will hit the parabola and come out at a nice straight line. So imagine the light bulb at this focus has rays of light going out in all directions, but any of these rays that are going toward the parabola are all focused outward in the same direction, giving the light bulb a nice solid beam of light. And it works opposite with a satellite dish, where the focus would be the receiver, and any radio waves coming in from the top are going to hit the satellite dish, the parabolic shape, and focus those rays back into the focus where they can all be received. The actual distance from the focus to the vertex, we'll call that distance p. And from this definition, we know that p is also found as the distance from the vertex down to the directrix. So this quantity p, it's important for us to know what that is. So given the equation of a parabola, we know exactly where to find the focus. We just showed a way to find the vertex, and now we'll talk about a way to find the focus. Let's look at some forms of equations of parabolas. Here are 4 standard forms of an equation for a parabola. Let's start with the first one. What we're used to really building off of is y equals x squared. We know it is a parabola with the vertex right at the origin. Pardon another bad sketch of one. It's good enough. We know it's touching there at the origin. Now if we can put this equation into the form x squared equals 4py, we'll be able to see exactly that value p, the distance from the vertex to the focus. So comparing these two equations, we can see that in this equation right here, what is 4p? Well, this is a coefficient of 1. So we're saying that 4p equals 1, so p is 1/4. That tells us that the distance for this parabola from the center to the vertex is a distance of 1/4. And the distance down to the directrix below is also 1/4. So our standard parabola y equals x squared, p equals 1/4. Our second form here, y squared equals 4p times x, is simply a parabola that is now symmetric on the x-axis. So we would see it opening to the right. Our last two forms are forms where the vertex is not necessarily at the origin. We still know that our vertex is found at hk. So seeing it in this form, we'll be able to quickly identify the x and y coordinates of the vertex, as well as the quantity p, which describes the distance from the vertex to the focus, and from the vertex to the directrix. Now let's go to the circle, which is defined as the set of all points xy that are equidistant from a given point called the center. So our circle is all these different points that have the exact same distance to the center. Here we're calling it at the coordinates hk. So any straight line we draw from the center outward, as long as we keep that line the exact same length, we're going to be extending this line to points on the circle. So this is why we're defining it as all the points that are equidistant have the same distance, and all those points will end up forming the points on the circle. Let's look at some equations for circles that we have. These equations should look very familiar to us. X squared plus y squared equals the radius squared. Very, very basic equation of a circle. And once we need to start accounting for shifting the circle to a new center, x minus h squared plus y minus k squared equals r squared. The radius is still found by our quantity on the right side, taking the square root, and our center is at the point hk. Yes, we were using it for a vertex at hk, and now we're calling it a center of a circle. We will know whether it's a vertex of a parabola or the center of a circle by the context. Remember, a circle has x squared and y squared. The parabola we just looked at had either x squared or y squared, but not both.